All right, so today we are going to continue about our transformations on trigonometric functions. We've already looked at transformations of sine and cosine. So next we're going to look at transformations of cosecant and secant graphs. And as you'll remember, cosecant and secant graphs are the reciprocals of sine and cosine. And so if you remember the parent functions, when we had learned the parent functions, I had suggested that if it's helpful, that you can go ahead and use sine and cosine, draw those in order to help you draw your cosecant and secant parent functions. The same thing's going to happen here as we're doing transformations of them today. So the first thing that we have here, when graphing transformations of cosecant and secant functions, it is easiest to first graph its corresponding transformed reciprocal function. So when we're doing these transformations, it's easiest if whatever the transformations are written in there, you can keep those transformations in there, and all you do is you change sine to cosecant or cosine to secant. Sorry, the other way around, cosecant to sine, secant to cosine, so that you can work with that. You know how to graph the transformations of sine and cosine. And then once you have those, you'll be able to graph its reciprocal function. One note, and I'll make note of this as we do examples, vertical asymptotes will go through the center line of the reciprocal function. What this means is, in order to help us, what we're going to do is we're going to start by drawing the center line. We're going to draw the sine or the cosine function as appropriate. And then once we've drawn that, we'll draw in the vertical asymptotes. And you'll look at where on the center line that sine or that cosine function crosses it. And that's where the vertical asymptotes will be. So we'll see this in example 1. So here's example 1. Graph y equals 2 times cosecant of x minus 1. Okay, so the first thing we're going to do is we are going to write this with the reciprocal function. So let's start with y equals 2 times sine of x minus 1. That's something that you should be able to graph. So I'm going to start by drawing in the center line. So because there are two transformations on this graph, there is the 2 out in front that changes the amplitude, and then there's the minus 1 at the end, and that shifts that down by 1. So we're going to start with that. The center line is going to shift down by 1. So here is our center line. All right, and then we have an amplitude of 2. So an amplitude of 2 means that from this center line, your function, your sine function, is going to go down by 2. So that's going to take you down to -3. And then it's going to go up from the center line by 2. So that's going to take you up to +1. Now we can draw our sine function. We know that the period of our sine function is going to be 2 pi. So we can just go ahead and draw 2 cycles of the graph here. All right, and the period of that function is 2 pi. We've labeled that. So now remember, this is just the reciprocal function. We want to be able to graph the cosecant function here, the transformed cosecant function. So what we're going to do is now we are going to draw in the vertical asymptotes. Now remember I said earlier we have to make sure those asymptotes are going to go through the center line where this sine function crosses the center line. So you find all those places where your sine function crosses that center line, that dotted line here, and we draw in the vertical asymptotes there. Draw them all in for these 2 cycles. And then once you have those drawn in, then you can draw in your cosecant function. So if you remember cosecant function, you take all your peaks in your sine function and you draw curves going off of those, and all your minimums, and draw curves going off of those. So again, remember that only the red portion is the actual cosecant function here, and the sine function here is in yellow. Okay, so if you want to, you can put it as like a dotted line as well, put in a different color, make sure it's very clear that those two are two different functions, and the cosecant function is only the one that's in red. All right, take a look at example 2. We have graph y equals 1/2 secant of 2x minus pi plus 3. Okay, now the first thing you're going to have to do, just like you did with your sine and your cosine functions when you dealt with transformations, is inside that secant function, you want to make sure that you have it in the correct form. Correct form meaning that you have a b value that has been factored out. So here, we are going to factor out the 2 and then deal with just x minus pi over 2. Now, if you want to do it at this point, or if you want to first change it to cosine, either way is fine, but eventually you'll have to go ahead and factor that out. So we factor out the 2, we're left with x minus pi over 2. So now you can see all the different parts here. You can see the amplitude is 1/2. You can see that it has been shifted up by 3. The b value is 2. Remember, that's not the period itself, but it helps you determine the period. So the period is going to be 2 pi divided by b, which is going to be 2 pi divided by 2, which is pi. And then the minus pi over 2 means we're shifting it over to the right by pi over 2. Okay, so we're going to do the same thing as we did before. We're going to start by graphing the cosine, the transformed cosine function, then draw in the vertical asymptotes, and then draw our secant function. So starting with the cosine function, let's start with the center line. So the entire function is shifted up by 3. So we're going to go ahead and draw 3 in here. Here's our center line. The amplitude is 1/2. So that means that this cosine function is going to go up to 3.5 and down to 2.5. Okay, so we'll go ahead and put those markings in. Okay, and then we also were saying earlier how the period of the function is 2 pi divided by b, which is 2 pi divided by 2 in this case. So the period of this function is pi. Okay, and then we also know that we've shifted over by pi over 2. So I'm going to put in pi here. I know that that's going to be one full cycle of the graph, but just to make it a little easier for ourselves, I'm going to start the cycle of the graph right at pi over 2, right? Because we've shifted over to the right by pi over 2. Now, if we start at pi over 2, that means that one full cycle is going to take us all the way out to 3 pi over 2. Okay, so now we can draw that in, pi over 2 to 3 pi over 2, so that's just a distance of pi. And let's draw another cycle of this graph here on the left. Okay, so that's our transformed cosine function. And to get our secant function, again, remember, start with the vertical asymptotes. So draw in the vertical asymptotes everywhere that your cosine function crosses that center line. Okay, so right there, 2, 3, and 4. Okay, and then just like we did in the first example, we are going to go ahead and draw those curves coming off of the max values, the curves going off of the min values. And again, remember that your just remember that your two graphs are in here. So be sure that you differentiate between which one is the secant function and which one is the cosine function. Okay, so we've done 2 examples where you have to come up with the graph of the function. We're going to do 2 examples where you're given the graph of the function and you have to come up with the equation. Okay, so in example 3, now again, similar to sine and cosine, you know that sine and cosine are really just the same graph but shifted over to the left or to the right by a certain amount, depending on what the period of that function is. So technically, you can always write any of these equations either as cosecant or as secant, because they're the reciprocals of sine and of cosine. So again, if it just said to determine the equation of the graph, you can come up with multiple equations. It could be in terms of secant, it could be in terms of cosecant. There are many ways to come up with a correct equation, and your neighbor could have a different answer than you. But if it does tell you to give a specific equation, do make sure that you are giving that specific one. So in this case, you're told to determine the cosecant equation of this graph. So we're going to make sure to give the cosecant equation. Okay, so let's go ahead and start by kind of similarly to graphing the equation. We're going to figure out where that center line is. So you want to take a look at that space in between, and you can see that it dips down to 1, and then on the bottom there it goes up to -5. So you want to find halfway between 1 and -5. You can easily do that by finding the average. So 1 plus -5 divided by 2, that's equal to -2. So our center line is at -2. So I'll go ahead and draw that in. Okay, and then this part's actually probably not too bad. You know how these curves come off of the max and the min values of, well, in this case, we're looking at a sine function, because sine is the reciprocal of cosecant. So that would be what the sine function looks like. Okay, so based off of that, let's go ahead and list off what the amplitude is, what the period is, and any other transformations that we may have to deal with. So looking at the sine graph that we've drawn in here in red, it looks like the amplitude is 3. Right, it goes, remember the amplitude is the distance from the center line up to the top, or the center line down to the bottom, or you can think of it as half of the distance from the max to the min, which would be 3. All right, the period of the function is the distance of one cycle, the length of one cycle. So it looks like here, the period of the function is pi. Now remember that that's not your b value. You determine the b value by setting your period equal to 2 pi over b. So let's write that out. So 2 pi over b is equal to pi, which means that b has to equal 2. And then it looks like the last transformation we have to take care of is how much it has shifted up or down. In this case, if you look at where the center line is, we can easily see that the entire graph has been shifted down by 2. Okay, so feel free to write down the sine equation if you'd like, but you know that once you write that down, all you have to do is take out the sine part and write cosecant in there instead. So this is going to be y equals 3 times cosecant of 2x in parentheses minus 2. All right, we have one last example, another one where you're given the graph and you have to come up with the equation. This time, instead of the cosecant equation, you'll come up with a secant equation. And again, you should be able to come up with one or the other, but just for practice, so that we get practice with both, we're going to write this one in terms of a secant equation. Okay, so we'll do the same thing again. We'll start off trying to draw in that center line. So it looks like we are in between 2 and 6. So halfway between 2 and 6 would be 4. So we'll draw the center line in here at 4. Okay, and then again, similarly to example 3, we are going to go ahead and draw in this case, the cosine function, which is the reciprocal of secant. And we're just going to make sure that the max and the min values of cosine will meet in the right places here. Okay, so now look at your cosine function, and let's write down the different transformations on this. All right, so it looks like if you try to find the amplitude, which is the distance between the center line to either the max or the min value, it looks like it goes up to a 2. So the amplitude is 2. Okay. And then the period. Okay, so if you look at the period of the cosine function, you can see if you start at 0, the length of one cycle goes all the way out to pi over 2. So your period is pi over 2. Now again, remember, this is not your b value. This is what 2 pi divided by b is equal to. So let's go ahead and write that in. 2 pi over b is equal to pi over 2. You get that b by itself. You should get that b is equal to 4. Okay, so that takes care of the amplitude, takes care of the period. It looks like we've shifted up. So again, look at that center line and see how far that's shifted. It looks like it's shifted up by 4. And then you can double check and see, are there any horizontal shifting left or right? And it looks like we don't have any. Or you can see it as, well, we do actually have a horizontal shifting left or right by pi over 2, but that's really just the same thing. You end up just overlapping onto itself. So don't make it harder than it has to be. We can just say this has not shifted left or right. Okay, so now we can go ahead and write down the equation of the graph. Again, you can write it in terms of cosine first if you'd like, but you know that at the end you'll just swap out the cosine with secant. So we have y equals 2 times secant of 4x, parentheses, plus 4. All right. So that is it for our graphing of secant and cosecant functions. Done examples of both where you have to start from the equation and come up with the graph, and also if you're given the graph, how you can come up with the equation. But always just remember, you can use sine and cosine to help you here. You know how to do transformations on sine and cosine, and then it's just a little bit extra work to get the secant or the cosecant equation or graph from there.